Hi everyone, welcome back to my channel. Welcome to Data Enthusiast Era. In this video, we are going deep into one of the most important parts of machine learning, data collection and preparation. If you have ever wondered how apps like Amazon or Swiggy predict what you want before you even click, it all starts here. Imagine you are building a grocery delivery app. Each user sees a unique homepage, their favorite snacks, last minute essentials, and personalized offers. How does this app know what to show? Through data, purchase history, browsing behavior, and shopping frequency. By this, the app will know what to show. The better the data, the better the predictions. Machine learning models doesn't just learn, they learn from data. Clean, centralized, and relevant data helps identify patterns, drive repeat purchases, improve customer retention, and ultimately boost revenue. In real companies, data doesn't live in one place. It's scattered across CRM systems, marketing tools, social media, IoT devices, analytic dashboard, and even Google Sheets. Each of these has a piece of the full history. To bring all the scattered data together, we use ETL, which stands for extract, transform, and load. Think of it as a three-step recipe for combining messy data into one clean dataset ready for analysis. First, we extract data from multiple sources, databases, APIs, files, or even social media platforms. Tools like Talent and DBT make this easier by automating data pulls and ensuring accuracy. Next, the transform step. Here we clean, normalize, and reformat data, fix missing values, correct inconsistencies, and standardize formats. This is where raw data becomes useful data. Finally, we load the transformed data into a central storage system, usually a data warehouse or data lake, from where it's ready for analytics, dashboards, and machine learning. What is data lake? A data lake is like a massive digital reservoir where all types of data, structured and unstructured, live together. It's scalable, flexible, and cost effective. Think of it as the backbone of modern data architecture. Data lakes allow centralized storage, handle all data types, scale easily, and integrate seamlessly with BI and ML tools. They also reduce cost because they use existing cloud storage systems. Companies like Tesla and Netflix rely on them heavily. Now comes the critical step, cleaning and transforming data. Raw data is like unrefined oil. Without cleaning, it's useless for machine learning. To improve data quality, focus on five key areas. Ensure accuracy, first one. Second one is remove duplicates. Third one is standardize formats. Fourth one is handle missing values. Fifth one is optimize for analysis. Depending on your project size, different tools can help you handle data effectively. For smaller datasets, use Pandas. For massive distributed data, Apache Spark is your friend. Other popular tools include AWS Glue, Talend, and dbt. Let's jump into quick hands-on example using Pandas. We'll clean and transform a mock data set step by step, handling missing values, decoding JSON, and adding derived columns. Sorry. We'll follow the step by step Pandas workflow, loading your CSV and then inspecting the missing values, and then fill the numeric gaps with median values, parse JSON fields, and then derive new features like salary category and address length, group and aggregate by department for insights. You might be wondering what is it all about. In some time we will go through that hands-on example, how we process this step by step flow. All of this contains collection, cleaning, transformation. Might sound tedious, but it's the heart of machine learning. A great model trained on bad data will always fail, but a simple model trained on clean, well prepared data, that's gold. So what we'll do is we will centralize and clean the data, use ETL to bring everything together, store it in scalable data lakes, transform it for analysis, and test your data quality before model training. So we'll follow all this and why it matters, transforming raw data into insights, what are the key takeaways, and if you have any queries, please send mail to this mail ID or you can comment below. We will now work on that hands-on project. If you have ever wanted to practice data cleaning or analysis but didn't have real data to work with, and this video is for you. I'll show you how to create a massive realistic data set from scratch using Python. We'll go line by line. So even if you have never coded before, you will walk away confident. Okay, let's jump in. So this is my Git repository. So always try to write or add the code whenever you are trying to develop something so that it will be useful in future. So this is my Git repository. So here are some existing repositories which I have created earlier. I want to create a new one for this task. So the repository name, I'm giving it as MLOps. Description, if you want, you can add it, or else we can leave it as it is. I'm keeping the visibility as public, and always add readme file so that we can add the steps which we are doing, and then just click on create repository. Okay, my new repository is created. Now I have opened Visual Studio Code, so it will be easy for us to access the code here. I am just cloning this repository. which path it is asking. I'll just give documents. Okay, if you see here, we have MLOps update. It's always good to add whatever you are developing in Git. Okay, now it is opened. If you see, we were on the main branch. We can continue to perform in the main branch. Here I am creating a new file, and first we will create one Python file. First we can rename this. Okay, let's write some code first. Let's start by importing the libraries that make this whole magic possible. First we'll import pandas as PD. Then import numpy as np. Then import json. Now import random. Now we have from datetime import datetime and time delta. So here is what each one does. Pandas is used to handle data like spreadsheets. We'll use it to create and save our dataset. NumPy helps us to generate random numbers fast. JSON lets us create nested information like addresses and emails inside one column. Random helps with general randomness like choosing random values or skipping some data. Date time and time delta help create realistic date ranges like higher dates from the past few years. Now let's jump into setting the random seed. np.random.seed 42. This line makes sure our results are reproducible. Think of it like setting a starting point for randomness. So if someone else runs your code, they'll get the exact same random data. It's like locking in the shuffle order. This line simplify and it tells Python how big our data set should be. We are going big, 20,000 records, enough to feel real, but still easy for your computer to handle it. Now we build the heart of our data set, the data dictionary. Okay, what this will do is ID gives each record a unique number from 1 to 20,000, like serial numbers in Excel. This line creates random names like name underscore 101 or name underscore 532, like that. We are using something called list comprehension. It's just a fancy way to say generate a list quickly. It picks random numbers between 1 and 1000, appends them to the word name. So we give each person an age between 18 and 80. NumPy's rand int means this will make that thing super easy. It's like saying give me 20,000 random ages within this range. Next one is salary. Let's give 50,000, 60,000, 70,000. Few are none. Yeah. So this part is cool. If each person gets a random salary, either 50,000, 60,000, or 70,000, or sometimes no value at all. The none represents missing data, and this helps you to practice how to handle incomplete data later on. Now, Oh, this one looks long, but stay with me. We are creating hire dates from today going back up to 10 years. That's 3650 days. I'll repeat that line again. We are creating hire dates from today going back up to 10 years. That's 3650 days. The line randomly subtracts days from the current date to make it look real. And if random.random gives a small number, we drop in a none, meaning that record has a missing date. About 10% of them will be missing. File JSON dumps address. Here let's give street 1200. Let's add city 1 to 50, and then here we can give phone. So here can add this one and this one. Okay, now here let's change the numbers. 1000, and here instead of zip, let's give email. Example.com, and here also we can change it to 0.1. So this part adds a realistic twist, a JSON column. Each person gets an address, phone number, and email all stored together as a single text field. In real datasets, you will often find columns like this. They look messy, but they are super useful for advanced analysis. Again, around 10% of them will be missing to simulate incomplete user data. Okay, now let's add department. HR, let's give IT, finance, marketing, sales is not needed. Now let's add bonus. Let's remove this. So none if random dot random is greater than 0.9, else random dot randint is 1000, 10,000. Oh, so we are adding departments randomly, HR, IT, finance or marketing, and then for bonuses, only about 10% of the employees will get one. The rest have none to represent no bonus or missing data. Now we'll take all those columns we built and wrap them inside a pandas data frame, basically a spreadsheet inside Python. We can now view it, sort it, clean it and analyze it all with code. Let's remove this np dot random choice df dot index. Instead of name, let's give salary and same np.na. So we are intentionally adding some missing values into age and salary columns. 5% of ages and 10% of salaries. So here this is 5%, this is 10%. So 5% of ages and 10% of the salaries will become NAN. That's Python's way of saying missing. This helps us simulate messy real world data and the kind of data scientists deal with every day. Let's give it a name, mock data. I think this is some indentation problem. Let's save this first. Okay, now it is saved. Let's run this. We need to check the terminal. Okay, I changed it to bash just by clicking this and git bash, or you can use WSL as well. Okay, let's try with this. Okay, first we'll install Pandas. So here it is saying pip is missing. Let's try with this. It is asking for password, but this is which password I'm still checking. Let's try with bash. It will take 1 or 2 minutes to install. Let's try to run this mock data. I think some issue it is showing. I'll just fix this one. So I just tried to upgrade Pip and Pandas again. Let's try. I got the problem here. Underscore is there. Okay, if you see, a CSV file got created. If you go to this path, see users, this one, and then OneDrive, documents, MLOps, and here is the CSV file. If you just open, so whatever the code we have given, these are the random numbers if you see, and the age, the salary, hire date, the address, street, city, phone number, department, and bonus. And if you see, some are missing as well. Let's close this. So now you have massive CSV file full of employee mock data, perfect for learning or testing machine learning pipeline. So what we just did is we have created the mock data .csv file using a Python. So you just built a 20,000 row realistic dataset from scratch using Python. In this, we will explore and clean this dataset using Pandas like a real data scientist. So I'm just pausing here. If you found this useful, hit that like button and drop a comment with your favorite part and subscribe to Data Enthusiast Era for more hands-on videos on DevOps, data, MLOps, and so on. Okay, we have done the data generation. We created a massive dataset using Python. Now it's time to explore it, to peek inside, understand its shape, and uncover what's really going on before we do any cleaning or modeling. So let's open this mock data CSV and start exploring step by step. Now we have to create one more .py file, data exploration.py. First, we import Pandas, the most essential library for data handling in Python. You can think of Pandas like Excel on steroids. It helps you read, explore, and analyze data with just few lines of code. The next step is this one. So here we are loading our CSV file into something called a data frame. That's just a pandas data table. The variable df now holds our entire dataset of 20,000 rows that we created earlier. The next step is df dot head. So what this will do is uh, this with this what we can do is we can have a quick peek at the top few rows. df dot head shows the first 5 records by default. This is your first reality check to confirm the data looks right. IDs, names, ages, salaries, departments, all the columns you expect. So what we can do is maybe let's try to run this. I think here we won't get any response. Let's try in Jupyter Notebook. Let's see if we can open that here. This one, right? Why it is not allowing? We have opened it in .py. The extension it is expecting is ipynb, like that. Let's see how we can run this. So however it's not allowing. Maybe let's try from here. ipy kernel. Okay, let's run. So some issue. I think some version issue or something. what what we have to do is let's copy this one. Okay, Let's run this one first. Okay, still some issue. Okay, I think in Jupyter it is not working. Issue with my Anaconda installation. We'll continue with this. So df.head shows the first five records by default to confirm whether the data looks right, IDs, names, ages, salaries, departments on all the columns you expected. This command gives you a quick structural overview of your dataset. You will see the column names, the data types, and how many non-null values exist in each column. Basically, it tells you what's complete, what's missing, and how the data is stored internally. So now this one is super useful. Is null checks which cells are missing and some adds them up column wise. So you will instantly know how many missing entries are in age, salary, hire date, and so on. So this command gives a full statistical summary like mean, median, min, max, and even unique counts for non-numeric columns. It's your one-shot overview to understand the distribution and spread of your data. For instance, you will know the average age, salary range, and how many unique departments there are. So let's give department and let's ask for unique values. So this final line shows up all unique department names that appear in your data. It's a simple but powerful check, especially to spot typos, duplicates, or inconsistent labels like HR versus HR, like capital HR versus small HR, like that. Okay, now can save it and in the terminal, let's run it. So if you see top 8 columns, it is showing non-null and ID, the types. So we just explored our dataset from top to bottom. We checked its structure, looked for missing values, reviewed basic statistics, and validated the unique entries. This step is called exploratory data analysis, or EDA is the foundation of any data project. It helps you understand what kind of cleaning or transformation your data will need. We'll move from exploration to data cleaning, fixing missing values, handling outliers, and preparing our dataset for ML pipelines. So I'm pausing it here. If you found this walkthrough helpful, hit that like button and subscribe to Data Enthusiast Era for more hands-on data tutorials that make you think like a data scientist. So we generated and explored a mock data set. Now we will clean it. Real data is messy. Cleaning it is whether the real work and the learning happens. So I'm just saying that cleaning it is where the real work and the learning happens. I'll explain every line like you have never written the code before. Let's jump into it. Now let's create one more file, data cleaning.py. As usual, let's import pandas. Next, import JSON. So what this does is we bring in tools. Pandas is our main data toolkit. Think of it as a Python spreadsheet. JSON helps us parse nested text fields that look like little dictionaries. Always import what you need at the top. Now df equal to, let's add this, pd.read CSV opens the CSV and loads it into a data frame named df. A data frame is just a table in the memory. Make sure the CSV file is in the same folder as your script, otherwise Python will complain it can't find the file. So we have added age, and here also let's add median. Some people will use median, some people will use mean, some people will use minimum, some people will use maximum. So in a project, we'll get that clarity from a product owner. If they are not confirming it, they'll ask you to make a choice on your own. So here we are taking median. So here is the thing, missing values break many analysis. We replace missing age and salary values with the column median. So why median means? Because it's robust to outliers. One extremely high salary won't skew it the way the mean would. In place equal to true means we change the data frame directly instead of creating and reassigning a new object. So if the whole column is empty, median returns NaN. So in production, you would check for that and choose a fallback. Now let's write department. Categorical columns are different. For department, we put unknown where there is no department. That preserves the row and makes it clear later that the department was missing instead of silently dropping it. Now print sample data after filling missing values. So always show results as you go. df.head prints the first 5 rows so you can eyeball whether fills make sense or not. This is excellent to show in your video. Okay, so this why I am showing it, because this df.head prints the first 5 rows. Here I am unable to show that. Let's try once. Okay, it is printing now if you see. So it is replaced with unknown, right? And here if you see NaN is there, like that it is replaced. Now let's go back here. Now df profile. So remember the profile column, it contains JSON strings like this one. This is the profile. This address, street, city, phone number, this. So remember the profile column, it contains JSON strings like address, phone number, email, all those things. We convert those strings into Python dictionaries using json.loads. If the cell is null, we will replace it with a empty dictionary so later code doesn't crash when trying to access the keys. That's what this one will do. So if json.loads fail because the string is malformed, it will raise an error. You can catch exceptions in more robust scripts. So here we are assuming that JSON is well performed or it is empty. Now let's print after converting profile column. Okay. So again verify, show the past dictionary. So we can check before and after. So let's run this again. So here if you see, this is the sample data after converting the profile column. Here if you see, double quotations were there. So this was changed to this one. Now address, let's add phone number and then email. What this does is we pull address, phone and email out of the nested dictionary and make new columns for them. Get, this is the key, and none. This returns none if the key is missing, so we can stay safe. Phone numbers are left as strings here. If you want to do numeric operations, you would convert them carefully because of leading zeros, uh, country codes and formatting. Now again, let's print and this again, run this Python file. So this reassures you have extracted correctly. you're seeing phone number, email. This comes as the columns. So this is the address, phone number, and email. So we have already changed these two different columns, right? So now profile is not needed anymore. We have already converted. The extra one is the extra profile is there. So we are removing it. We have already pulled out the useful bits, so we drop profile to keep the table tidy. In place equal to true modifies the data frame correctly. If you want to keep raw JSON for audit, skip the drop or save a copy before dropping. Now you can print again with final data sample, print df head, comma, we are placing it in some space. Let's run this. Okay, if you see, address, phone number, email were added and profile was dropped. This table should now have the new address, phone number and the email, no profile column. Now df index false, print. So this writes the clean data frame back to disk. Index equal to false avoids adding an extra numeric index column. So we are just printing a confirmation. Let's rerun again. So here if you see, this is the cleaned data frame. NA is there, unknown is there. So before concluding this cleaning data, always check data types, df.dtypes. Sometimes salary might be an object or a string. You need pd.to numeric before calculating the medians. For reproducibility, show df.shape to confirm row or column counts. And cleaning data isn't easy, but it is essential. After this, your dataset is ready for feature engineering or model training. If you want, I can write a short code cell to show how to convert phone numbers to a consistent format or how to check duplicate rows. And hit that like button if it helped and subscribe for the more such videos. We will do feature engineering, preparing data for ML model and all that. Okay, we'll now jump into data transformation. Now we are taking the next big step, transforming our clean dataset into something truly insightful. We will create new columns, categorize salaries, and generate a summary report, just like the real data analyst does before visualizing and modeling. Let's start. Let's create one more file. This is data x, not x, transformation. All right, Let's start it with pd and import JSON. So we start by importing our tools again, pandas for data manipulation and JSON in case we need to work with nested data later. You will use pandas in almost every stage of the data project. Df equal to pd.read. Now this is not needed. This is not a cleaned one. Let's start with cleaned data. Here we load our clean data file from the previous step. This file already has missing values handled and the profile column dropped, and now we are going to transform it into something more analysis ready. Now address, let's add address length, df address apply lambda, adding string of x. Here is where transformation begins. We are adding a new column called address length. That means how long each person's address string is. We wrap x in string to avoid errors when an address might be none. This might sound small, but feature engineering like this is exactly where data scientists do, turning existing data into new insights. Now let's print. Always preview what you have created. Here we'll print the first few rows of the address and its calculated length to confirm it worked. So let's run data transformation. Okay, if you see, address is added and address length is added. Now let's add bins. Zero, 50,000, 70,000, 1 lakh. And then labels, low, medium and high. Now we are setting up the ranges or the bins for salary categories. Anyone earning up to 50,000 is low, between 50,000 to 70,000 is medium, and above 70,000 is high. We'll use these bins to categorize each person's salary into a labeled group. Now what we are doing is df salary bins. Here the transformation is in action. We are using pandas cut function to split numeric salary into our defined categories. The result, each person now has new columns salary category that's easier to analyze or visualize later. Let's print this. And this, let's bring the first few rows again. This confirms that numeric salaries are now translated into meaningful categories: low, medium, or high. Again, just rerun this. Okay, if you see 60,000 is medium, 50,000 is low, and if it's above 70,000, it will be high. Now, let's add summary report. Age, and let's close this. So this one is the most powerful step in Pandas grouping. Here we group our dataset by department, and for each department we calculate the average salary and average age. This is exactly how analysts summarize trends in the organization, for example, comparing department wise pay scales. So summary report can keep this as dot columns equal to not salary department. Let's remove this department average salary, and then average age. So after grouping, we rename the columns so they are clean and ready. Good naming practices matter. They make your output easier to read and share. Okay, now let's print our summary. Think closing parenthesis. I think here we forgot to add the parenthesis. Okay, now just rerun. Okay, now department year, comma, average salary and average age. We are not renaming it. Rerun. Okay, if you see the average salary, the average age in each department. Each department, its average salary, average employees, all computed directly with some few lines of code. This is kind of data analysts use to make real business decisions. Now we have to save the transform data. Finally, we save everything into a new file called transformdata.csv. This keeps our flow structured: one file for raw data, one for cleaned data, and one for transformed data ready for the insights or dashboards. Let's rerun, and if you see, got created again. So if you want, we can just open the transformed data, right? So if you see, it is the fixed one, the final data which you have transformed. You just transformed raw data into rich, meaningful insights using Pandas. You learned how to engineer new features, categorize data, and summarize it like a pro. So, if you found this helpful, hit the like button and comment your favorite part and subscribe to Data Enthusiast Era, where we make data feel easy and exciting. Thanks for watching.